Okay, in this video we're going to look at the intersection between a line and a circle. And the second part of the video we're going to look at questions involving the discriminant. So let's take this first example. Find the coordinates of the points where the line y equals x plus 5 meets the circle x squared plus y minus 2 all squared equals to 29. So what we're going to do is write the circle equation out. So I'm going to write x squared plus y minus 2 all squared equals to 29. And then what we're going to do here is substitute for y the equation of the straight line, which is x plus 5. So this is essentially solving a simultaneous equation via substitution. So minus 2 all squared equals 29. So x squared, improve the clarity of my handwriting, x squared plus, we get x plus 3 all squared equals to 29. Now previously in other videos I've stated that there's a well-known identity at GCSE that you would have been taught. A plus b all squared is a squared plus 2ab plus b squared, and the other one would be a minus b all squared is going to be a squared minus 2ab plus b squared. Now here we've got x squared, then here we've got x squared plus 6x plus 9. Now this is equal to 29. This is 2x squared plus 6x plus 9 equals to 29. Now all quadratic equations must be equal to 0. So we can say minus 29 on both sides. Therefore we have 2x squared plus 6x minus 20 equals to 0. We can divide throughout by 2. So this symbol is called this implies. So we get x squared plus 3x minus 10 equals to 0. So we're going to factorize the quadratic. X plus 5 x minus 2 equals to 0. Solving that gives me x minus 5 or x equals 2. But we want to find the coordinates, so we need to find the y values. So we can use a linear equation for that. Y equals x plus 5. So I'm going to write that here. Y equals to x plus 5. So when x equals minus 5, therefore y equals to minus 5 plus 5, which is 0. So the first point of intersection is minus 5 and 0. Do the same thing here. So when x equals 2, y equals to 2 plus 5, y equals to 7. I've just written it in purple so it doesn't get too confusing. So now the second point of intersection is 2 and 7 respectively. Here's a question for you to try. You can pause this video, and when you're done I will go through my work solution. Okay, welcome back. So this is identical to our example, so we're going to start off by writing down our equation of the circle x minus 3 all squared plus y minus 5 all squared. Now that's equal to 34. Then we're going to do a substitution, x minus 3 all squared plus. Now we're going to substitute what y is, that's x plus 4. Don't forget we need to do a minus 5. All squared equals to 34. So that gives me x minus 3 squared plus x minus 1 squared equals to 34. So it gives me x squared minus 6x plus 9 plus x squared minus 2x plus 1. That's equal to 34. So I get 2x squared minus 8x plus 10 equals to 34. Minus 34 on both sides. So that gives me 2x squared minus 8x minus 24 equals 0. Divide by 2. This implies that x squared minus 4x minus 12 equals to 0. So we get x minus 6 x plus 2 equals to 0. So we're going to get x equals 6 or x equals to minus 2. Writing our y equation down, which was y equals to x plus 4. Just go double check that. Yep. So you write that underneath it. Y equals x plus 4. So we can say when x equals to 6, y is equal to 6 plus 4, y equals 10. So the first points of intersection are 6 and 10. Then y equals x plus 4 here. And that's going to be minus 2, comma 2. So here's the next type. So the next type we need to look at is when a line meets a circle. So if the line intersects the circle at 2 points, we're going to say the discriminant for b squared minus 4ac is greater than 0. That's two distinct real solutions or points of intersection. And this is very similar to what you do in chapter 2 in quadratics, where a straight line intersects a parabola. The second case is b squared minus 4ac is equal to 0, so you get one intersection point or one repeated solution, one repeated real solution, hence 1 point of intersection between the line and the circle. And the final case is when the line does not touch the circle, b squared minus 4ac will always be less than 0. So we say no intersection point or no real solutions. So these are going to be our three cases that we're going to be looking at. So let's take this example here. Show that the line y equals x minus 7 does not meet the circle x plus 2 all squared plus y squared equals 33. So like the previous case, we're going to do substitution. So x plus 2 all squared. Now I'm going to replace the y here with x minus 7 all squared. Now that is equal to 33. Now I've said to you previously that there's a well-known algebraic identity in algebra, which is a plus b all squared is a squared plus 2ab plus b squared, and that the second case is that a minus b all squared is equal to a squared minus 2ab plus b squared. Now, I'm just going to put this here so you can use this in your notes. So let's use that here. So we're going to get x squared plus 4x plus 4. So here we're going to get plus x squared minus 14x plus 49. And that's equal to 33. So we get 2x squared minus 10x plus 4 plus 49 minus 33 equals to 0. So we get 2x squared minus 10x. Well, that's going to give me 53 minus 33 is 20. So that's going to be plus 20 equals to 0. So divide by 2. That's x squared minus 5x plus 10. Well, this can't be factorized. Don't forget it's 1x squared. So we're going to say a equals to 1, b equals to minus 5, and c equals to positive 10. So therefore, b squared minus 4ac, what does that give me? Well, I get minus 5 all squared minus 4 times 1 times 10. Well, 25 minus 40 is certainly minus 15, which is less than 0. So we're going to say, since b squared minus 4ac is less than 0, y equals x minus 7 does not intercept the circle. With the circle. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, so show that the line x plus y equals 11 meets a circle with equation x squared plus y minus 3 all squared equals 32. That's only 1 point for 4 marks, and hence for part B, we need to find the coordinates of the points of intersection. So the first thing we ought to do here is to rearrange the linear equation in terms of y. So that's going to be minus x plus 11. Do a substitution, so x squared minus x plus 11, and then we get minus 3 squared, and that's going to be equal to 32. So now what we get x squared plus, now 11 minus 3, that's going to give me 8, so I'm going to get 8 minus x all squared equals to 32. So x squared plus, that's going to give me 64 minus 16x plus x squared equals to 32. 2x squared minus 16x plus 64 minus 32 equals 0. So now we're going to get 2x squared minus 16x plus 32 equals 0. Now we can divide throughout by 2. This implies, so we get x squared minus 8x plus 16 equals to 0. So a is 1, b is minus 8, c is 16. So now we have to use the discriminant here. So we're going to say b squared minus 4ac. So that's going to be minus 8 all squared minus 4 times 1 times 16. So we're going to get 64 minus 64, and that's exactly 0. So therefore, since b squared minus 4ac equals to 0, we can say x plus y, or therefore x plus y equals 11 meets the circle, or intersects the circle at only 1 point. I should really use the word intersects. It's better, it's more formal. Now part B says to find the points of intersection. So if we go back to our quadratic, we formed a quadratic equation here where we had x squared minus 8x plus 16 equals 0. So I'm going to write that here. So part B, we've got our quadratic x squared minus 8x plus 16 equals to 0. And I got that earlier, or I derived that earlier here. So as you can see in the previous line. So now we're going to factorize this. So we get x minus 4 equals 0. So we get a repeated solution. In our case, x equals 4 or x equals 4. I'm just writing this out to show it's a repeated solution. Some people could say x equals 4 only. Is the only intersection point, it's fine. So we could write down the y equation. Now our y equation was, go back to what they've given us, so it's going to be minus x plus 11. So we do minus x plus 11 here. Say when x equals 4, y equals to minus 4 plus 11, y equals 7. Therefore, the points of intersection are 4 and 7.